So let's just see how the heap sort code works in details. So as we know, heap sort is a comparison based sorting algorithm. Here it uses the binary heap, which is basically a complete binary tree. So suppose we wanted to sort these array elements. So first of all, we have to create one complete binary tree. That means in the tree all the levels will be filled from left to right. So first of all, we're gonna have 1, then 5, then we're gonna have 2 and 8, and then we're gonna have this 7. So all the levels will be filled from left to right in a complete binary tree. Now to sort this into ascending order, we have to create one max heap. So the first step is to build one max heap. We have to convert the array into one max heap, where the parent node will have larger value than both of its childs. So currently you can see it is not max heap, so we have to convert this into one max heap. So for that we're gonna use this Heapify function. So this function will make sure that we have the max heap property in a subtree. So suppose we have one subtree. Now we can pass this array into this Heapify function, and the size of the array and the index of this root element. Now the function will perform Heapify to this root element, and it will make sure that the root node has the larger value than both of its childs. So let's just see how the function is working. So first of all, we're gonna consider the index I as the largest element. So here we're gonna assume the I is the largest. So first of all, we're gonna get the index of the left child using 2i plus 1. So we're gonna get the index of the left child, and then we're gonna get the index of the right child by using 2i plus 2. So we're gonna get the index of this child. Now we have to perform the comparison. So initially we're considering that the root node has the largest value, and now we're gonna compare with the left and the right child. So first of all, we are checking if the left is less than n. So if we have the left node, so if the left node exists and the left node value is greater than the largest value, so that means if the left node value is greater than the root node's value, so in that case we're gonna update the largest to the left node. So initially the largest was pointing to this root node. So if we found that the left node has the larger value, then the largest pointer will point to this left child. And after that we're gonna compare with the right child. So if we have the right child, so if the right is less than n and the right child value is greater than largest, in that case we're gonna update the largest to point to this right child. So you can see, because the left child has the larger value, so this largest pointer will point to this left child. And after that, here we have to perform the swapping. So if we see that the largest pointer is not pointing to the root, that means either the largest is pointing to the left child or the right child, whichever has the larger value. So in that case we have to swap them. So we're gonna swap the root node with the largest value. So in that case we're gonna swap this root node value 7, and we're gonna swap it with this left child. And after that we have to recursively apply this Heapify the whole process to make sure that the affected subtree also have this max heap property. So again we're gonna call this Heapify with the array, the size, and then the largest. So that means we're gonna apply the Heapify for this left child also, because that is modified. Because this time this is a leaf node, so this will not work. So after the end of this heapifying process, you can see the root node has the larger value than both of its childs. And this is how the Heapify is working. So now the thing is that we have to apply this heapifying process to our tree so that the root node has the larger value than all of its childs. So here we have the heap sort function. So initially we're gonna call this heap sort function with the array of unsorted elements, and then we're gonna pass the size of this array. So first of all we're gonna build one max heap. So the first step is to build the max heap, means the root node should have the value greater than both of its childs. So to create the max heap, we are using the for loop. So the loop will run from the last non-leaf element. So the I will run from n by 2 minus 1. That means from this last non-leaf element. So these are the leaf elements because they do not have any child, and this is the last non-leaf element because it had child. So we're gonna start from this last non-leaf element and we're gonna continue till we reach the root node. So first of all, we're gonna apply Heapify here, then we're gonna apply Heapify here, and then we're gonna apply Heapify here. So in the for loop, we're calling this Heapify function with the array, size, and the index where we wanted to apply the Heapify. So currently we are applying Heapifying to this last non-leaf element. So the Heapify function will compare this parent value with the child value. So because 7 is larger than 5, so 7 and 5 will be swapped so that the parent node has the larger value. And again, we're going to apply the Heapify for the next non-leaf element. So this time, because 8 is larger than 1, so 1 and 8 will be swapped. And again, we're going to apply the Heapify for this root node. So because 8 is larger than 3, so 3 and 8 will be swapped. So after the end of this for loop, you can see our tree is converted to one max heap. That means the root node has the larger value. So now the next step is to extract the larger value from the root node. So to extract the root node, we have to swap this root node value with this last node. So here we are using the for loop. So the for loop will run from n-1 till I greater than 0. And now each iteration, we're gonna swap the root node with the last node. So that means 8 and the last value 5 will be swapped because the 8 is the largest value. So the 8 will be stored into a resultant array and the heap size will be reduced. And next we have to apply the Heapify to restore the heap property. So because we have swapped with the last node, so we have to again call the Heapify function with the array, the reduced size, and we are sending the index 0 to perform the Heapify to this root node because this value came from the last node. So Heapifying means the Heapify function will compare this root value with both of its childs, and because 7 is larger than 5, so 7 and 5 will be swapped. So now the tree is one max heap. Now we have to repeat both of this process. That means again we have to extract the value from the root. So that means the 7 will be extracted, it will be swapped with the last value, and the last value 1 will go in the root position, and 7 will be the next resultant value. So this way the process will continue. So one by one we're gonna perform the Heapify, then we're gonna swap, and this way one by one we're gonna get the largest value from the root of the tree. So next the larger value 5 will be swapped with the root node. So again we have to extract the larger value from the root. So one by one we're gonna get the larger values in our resultant array. So here we have the code for the heap sort. So here is the Heapify function. Then we have the heap sort function. Now inside the main method, here we're gonna create one array. So the array will contain these values. Now we can call the heap sort function and we can pass the array, the size of the array. Now after performing the heap sort, now we can print the array. So you can see after applying the heap sort, now the array elements are sorted. So hope you understand about the working of the heap sort function. See you in the next one. Take care.